These are the solutions to your transformations review sheet. Because number one has a lot of different answers, I am just going to show those. Feel free to pause it so that you can have a chance to check all of your answers. All right, part K, which of the above transformations will give you a congruent image and which will give you a similar image? The big thing that you need to know for this, anytime you are using reflections, rotations, or translations, you are going to get a congruent image. Even if you are reflecting it and it's not facing the same direction, that's okay. It still counts as congruent because it's the same shape, same size. If we cut them both out of paper, we could get them to match up. Um, Anytime that you are using a dilation, whether it's by itself or with any of the other transformations, you will get a similar image because a dilation will change the size. Although it will still be similar, you'll have the same angles and all of your side lengths will be proportional. On number two, a quick reminder about your quadrant. So you start on the top right-hand side and count around in the shape of a C. 1, 2, 3, 4. If you start in quadrant 4, where this red circle is, and you reflect it over the y-axis, it will end up in quadrant 3. So just make sure you know your quadrants for that and your x and y-axis. Okay, next, if you reflect something over the x and then reflect it over the y, that is the same as a 180-degree rotation around the origin. So you'll notice each of the 6 numbers in your coordinate points, you are doing the opposite of it. So if it was negative, it's now positive. If it was positive, it's now negative. So each coordinate is the opposite of the original value. All right, number 4, a couple of these have more than one option. I just did some of the more obvious choices. Part A, that's the same as going left 2, down 4. I do need you to make sure that you understand how to write the coordinate points. So if you're going left 2, that is x minus 2. If you're going down 4, that would be y minus 4. Right below that, same thing. Left 1 means x minus 1. Down 3 means y minus 3. Okay, parts D and B have a couple different options. So you can do the translation, you can move up 6, or you can also be reflecting over the x-axis because you're just changing your y value from -3 to +3. And if you are changing your y value to its opposite, you're reflecting over the x-axis. If you change your x values to the opposite, you're reflecting over the y-axis. Part D, you can do the translation. That's the more obvious of the transformations you could choose. Or you could rotate it 180 degrees around the origin, and you're going from quadrant 1 down to quadrant 3. All right, part 5. All of these transformations go off of each other. So they're kind of combined. On part A, that one's in red, so you'll see that it was reflected over the x-axis. Part B is in blue, that was a 270-degree clockwise rotation around K. Part C, you reflected across the y and then across the x to get down to the third quadrant. And then on part D, you're going to come up with another possible way of how you could get from one to the other. So one option, and again, yours doesn't have to match mine, you could reflect it over the line x equals -3. So that's this dotted line right here connecting L and K. You can reflect it over that line, then rotate it 90 degrees clockwise around K. So that would get you to that second one in red. And then you could translate it 4 units down, and that would be another option. You can also change the order of any of those. So you could first translate it down 4, then you could reflect it, then you could rotate it, and you would get to the same thing. Not every single combination of those will work, but you could tweak them just a little bit. All right, part 6. You need to come up with at least 2 different ways to go from JLZ to J prime L prime Z prime. Um, Again, yours might not match mine. That's okay. You just need to make sure that they will work. One option is to rotate 270 degrees clockwise around point Z and then translate it left 7 and down 4. Another option is to rotate it 90 degrees counterclockwise, because we know 270 degrees clockwise is the same as 90 degrees counterclockwise. Then we could translate it 4 down and then left 7. Um, both of those pretty much say the same thing, so if you could be a little bit more creative, that would be great, but that would be enough to get you points on a question like that. All right, number 7. This one, you need to come up with your own coordinate points. So in red, I have an example of what it could be. Yours might be a little bit different. I started with each of the sides. So side AB, I am comparing the side lengths -2, or the values -2 and 6. That is an 8-unit difference, so I know that that side is 8 units long. Then I can look at B and C, and right here, -2 to 4 is a 6-unit difference, so that side is 6 units long. I'm going to compare this with a ratio doing short side divided by long side, so that would be 6/8, and that simplifies to 3/4. So I just need to make a rectangle that will have the side length simplify down to 3/4. I chose a rectangle with side lengths of 9 and 12, and I put it at the origin, so it would be really easy to write all of my points. Then you can see if I do short side over long side, I get 9/12, and that simplifies down to 3/4. So the proportion I could write was 9/12 equals 6/8, and that proves that both sides are similar, and since the side lengths are different, I know that they are not congruent. All right, part A. This one's a little bit different from what we've been doing in class, only because it's lines instead of shapes, but that's okay, we can still handle it. Um, Part A, which transformation would result in a line segment parallel to the original. So in red, that one's the original line. Any translation, up, down, left, right, any translation will still give you a parallel line. So in blue, I have 2 possible examples. One was just translated 2 units down. The other was translated 2 units to the right. Part C, a 90-degree rotation in either direction will give you a line segment that is perpendicular to the original. So remember that perpendicular means that the 2 lines form a 90-degree angle. And then I also translated it, so I had a rotation and a translation to get the 2 line segments that I chose. Again, yours don't have to match perfectly, but they do need to be parallel or perpendicular. All right, final problem. We have an original shape in red in the middle, and we need to be really specific and explain or say how we can get to any of the others. So the first shape, shape 1, one possible way to get there is a 90-degree clockwise rotation around point B, and then you can translate it 7 units right, 3 units down. On all 4 of these, yours might be different, and that's okay. I will be checking each individual answer when we get to the test. Okay, number 2, that was a dilation. It was also an enlargement because the scale factor was bigger than 1. To go from side length of 2 to get to a side length of 3, you have to do 2 multiplied by 1.5. So that's how I knew that my scale took one of the sides and multiplied it to get to the other. Okay, shape 3. One possibility would be a 90-degree clockwise rotation around vertex B, then a horizontal reflection over, and I should probably say the line segment AB. Okay, so that's a vertical line now. Then translate it down 7 and left 7. Okay, and then finally, number 4, that one was just a straight translation. We went down 7, left 1, or you could say left 1, down 7. All right, I can't stress enough, be prepared to be able to come up with your own transformations to show how to get from one shape to another. Make sure you're studying your vocabulary. Go back and look at any of the previous assignments that you've done on your checklist or also on your quiz. Good luck.